So here we have our problem. A surveyor stands at point A, which is due south of the tower OT. So in other words, here we have A at the tower, O, due south, we have point A. The angle of elevation to the top of the tower from point A is 45 degrees. Now if you think about that, there's A, there's the top of the tower, that angle there is 45 degrees, then that must mean that if H is the height of the tower, that this distance is also H. So we can land a label on our other diagram, this is distance H. The surveyor walks 100 metres due east, so goes 100 metres due east, and of course that's 90 degrees. There's point B. Okay, so now we're looking down from above, we have this particular diagram. Now we're also told, must put on that there, we're also told that the angle of elevation from point B is 30 degrees. So if we draw a diagram with this one, now in this diagram, this is point O, this is B, this is the tower we're looking up, so that's 30 degrees in there, that's a right angle, that's the top of the tower, and that's the height. Okay, now if we take a look at our first diagram with the H and the 100 in it, positioning A directly south of the tower, we can find from Pythagoras that that distance OB is going to be H squared plus 100 squared. Simple Pythagoras. Okay, so from the second diagram, so this, let's call this 1, diagram 1, diagram 2. From diagram 2, we can see that tan 30 degrees is going to be equal to H over OB, and from our first diagram, that's going to be the square root of H squared plus 100 squared. Pretty dodgy H. There we go. So that's going to be what we work with now. Let's go to do this again. So what we have is that tan 30 degrees is equal to H over the square root of H squared plus 100 squared. Now if you remember, tan of 30 degrees is equal to tan 30 degrees is equal to 1 over root 3, dodgy 3. So 1 over root 3 is equal to H over the square root of H squared plus 100 squared. Resolve this, cross multiply, whatever you want to call it by. H root 3 is equal to the square root of H squared plus 100 squared. Now that is pretty useless to us, so let's get rid of those square roots. So we'll square both sides. So on the left hand side we're going to have 3h squared is equal to h squared plus 100 squared. So move the h squared from the right hand side to the left hand side, we get 2h squared is equal to 100 squared. So h squared is going to be a half times 100 times 100, which is going to be 2 times 25 times 100. So now take the square root of both sides. Whoops. Undo that. So take the square root of both sides. H is going to be equal to, well, the square root of 25 is 5. Square root of 100 is 10. 10 times 5 is 50. and square root of 2, square root of 2. Okay, so we can see that we've done the things of part 1 and part 2. Let's go back to our original diagram, which is this one, number 1. We know that this distance here was 100 between A and B. We know that this distance now is 50 root 2. If we can find this angle here, theta, then we can take it away from 180 and we can get the true bearing of B from O, because remember, true bearings come from north in a clockwise direction. So if we can find the angle just here, we can take it away from 180. So we have, relative to theta, we have the opposite and adjacent. So we know that tan theta is 100 over 50 root 2. So tan theta is going to be 50s into 100 is 2, so it's 2 on root 2, which is equal to root 2. So theta equals tan to the minus 1 of root 2. Calculator, and you get that angle, which turns out to be 54 degrees and 44 minutes. So bearing of B from O, whoa, that should be O, not theta. Let's undo that. O is 180 minus 54, 44. So let's do on the calculator 180 degrees minus, where's the answer gone? Answer equals 125 degrees, 16 minutes, true. Here endeth the problem.